Good morning, good afternoon, or good evening to all of you. Today we're on to lesson 5, and that means we're looking at the internet.
Ladies and gentlemen, I'd like to present to you the internet. Oh, please, no flash photography. You'll harm the internet.
So we've done a whole chunk of this now, so we can get rid of most of that. And today we're going to be looking at all this stuff here. So it'll be quite a long video for me, maybe a bit longer than usual. So the internet, as we should know, is a global system of linked computer networks. There are many different technologies needed to help everything work together. And some of these technologies we're going to look at, and these are URLs, IP addresses, DNS, hosting, and the cloud. So we'll take a look at them each in turn during this video lesson. URL stands for Uniform Resource Locator, and this is the unique web address for each website. Commonly, we just call it an address or a web address. So we've got a couple of examples here for bbc.co.uk or google.com, and these are both examples of URLs. So of course, each page on the internet has a different address, a different URL. You don't really need to know too much about how URLs are actually made up, just as long as you know roughly what they are. Moving on to IP addresses, every computer device connected to the internet has its own unique address. This is known as the IP address, the Internet Protocol address. So an example here would be 76.215.67.190. Without an IP address, devices cannot send or receive information on wide area networks such as the internet. It's the same way that we need a postal address if we want to send a letter. So this number is an example of what we call an IP version 4 address, 172.168.254.1. And you can see in reality, of course, this would be a binary sequence. We're just using regular numbers because it's easier for us to understand. And obviously you need an IP address so you can identify who you are, your address, and you can also identify the address where you want to send or receive information from. So there's a problem here. Computers use IP addresses. However, people aren't very good at memorizing long strings of numbers. So we use URLs to identify resources that we want on the internet. So the example here would be facebook.com, which is a lot easier to remember than, say, 31.13.90.36. So the question is, how does your computer know that when you type in facebook.com that it has to go to the location 31.13.90.36? Well, that brings us to DNS, the Domain Name System. You can think of this roughly as the internet's equivalent of a phone book. It contains each domain name, like google.com, and its matching IP address. So for example, when I was researching this lesson, I checked, and one of the many IP addresses that will take you to google.com is 216.58.212.228. In fact, if you type that directly into your web browser, that's the IP address, it will take you straight to google.com. So this information is held in a large database. Now, there are a lot of what we call domain name servers around the world that contain this information. So there's a map here of some different DNS server locations around the world. As you can see, there are lots of them. And in fact, there's not just one domain name server that contains all the URLs and all the IP addresses. They all contain part of this information, and they work together so that you can match any URL to any IP address and vice versa. So let's have a quick look at how DNS works. This is really simplified. You don't need to know the full story at GCSE level because it does get very complicated. This is a simplified version.
You can't handle the truth!
So you type the URL into your web browser. The browser sends a request to a DNS server. The DNS server finds the IP address for the website you want to access. If the DNS server doesn't have a record for that domain name, it makes a request to another DNS server that is connected to. The IP address is sent back to your web browser. If it is not found, an error message is returned. Your web browser then uses the IP address to find the server hosting the website that you want and asks it to send a copy of that web page to your computer. So again, we can have a look at that in kind of diagram form. This is my computer in the middle. I want to go to a certain website. My computer doesn't know what the IP address is for that website. So my computer arranges a DNS query to a DNS server that will match my URL to an IP address. In this case, this one here. It sends it back to my computer so that my web browser can then send a packet of data to the web server requesting that information then be returned to my computer. So this doesn't necessarily happen every time you type in a URL. Your computer will have cached copies of the IP addresses for websites that you visit regularly. Your ISP, your internet service provider, will also have a copy of different websites and how they match the IP to the URL. So it's only maybe if you haven't typed in that website for a long time that it has to perform this query. It's not something that happens every time. Moving on, let's look at hosting. Websites and other internet services need to be placed on a web server. This is known as hosting. An internet host is a company that runs servers to provide different types of content via the internet. This may include file hosting, web hosting, email hosting, video hosting, and game servers. Content can then be accessed from any device connected to the internet. Often, hosting companies will charge a monthly fee in order to use the facilities provided by their servers. Somebody has to pay for that hardware, the electricity, the maintenance, things like that. Sometimes you can access a limited amount of content for free. For example, a number of hosts provide a limited amount of space to store files in the cloud for free, but additional space has to be purchased. So if you want to put your website on a web server so other people can access it, maybe that'll be free if it's a small scale website, but if you start getting a lot of traffic, you're probably going to have to start paying them some money to maintain that access. So every website is hosted on a web server. This is a dedicated computer on the internet that responds to HTTP and HTTPS requests by returning web pages. So remember the difference between HTTP and HTTPS. HTTP is not encrypted. The S in HTTPS means it's a secure encrypted connection. It is possible for anyone to set up their own web server, what we call local hosting, but people usually use a web hosting company unless they really know what they're doing and they're very confident. The hosting company will generally charge a monthly fee to host the website in its data centers. Larger or more popular sites that consume more bandwidth will be charged more each month than a smaller site that requires less bandwidth. So it's scalable. You start your own e-commerce company, maybe you don't need to pay a lot of money at the start, but if it blows up and becomes really popular, you'll probably want to pay for greater access so that more people can use your service at the same time. Web hosting often includes domain name registration, which ensures that the chosen name for that website has not already been taken, and it is then registered on the domain name server. So again, you want www.example.com, you'll need to pay a company to access that and have it for yourself. Web hosting companies will usually offer service guarantees, ensuring that a website will be available to visitors most of the time. Obviously, if you want 365 days a year, 24 hours a day, absolute perfect uptime, that'll cost you a little bit more. They will also make regular backups of the data and will apply appropriate security measures to keep a website safe from cyber attacks. As well as web servers, we have clients. Client computers request files from a server. When you visit a website, the browser on your device requests the web page from a web server and they are downloaded to your device. So we looked at this already when we looked at client-server networks. It works in the same way. We've mentioned the cloud before in this lesson. I'm sure most of you are fairly familiar with the cloud and cloud computing, but just make sure that you do have that strength of knowledge to make sure you can answer questions about it in the exam. So cloud computing is when people make use of software and services via the internet. The key idea here is that the files and the software that you're using aren't located on your actual device, they're located somewhere on the internet, on the cloud. And then you can access it from any device, from any location. The cloud is a sort of generic term that refers to storage, services, and applications that are accessed via the internet rather than being stored locally on your computer, tablet, or phone. The cloud is effectively a network of servers, some that store data and others that run applications. These services are housed in giant data centers around the world, and users do not actually need to know the geographical location where their data is stored. But it is important to remember there is actually a data center somewhere in the world that actually has your data or that hosts the software that you're using. It's not just dispersed randomly around the world. There is somewhere a physical location that does actually have it. So I'm sure you're familiar with a lot of different cloud services, but here's a reminder. You've got online storage, things like Dropbox, OneDrive, iCloud. You've got lots of online apps that you can use like Google Docs or the online version of Office 365, streaming services like YouTube and Spotify and Netflix and all that sort of stuff. More professional applications like Amazon Web Services or Microsoft Azure. These are all located on the cloud computing. So why do we use cloud computing? What are the advantages? Well, data can be accessed from any device, from any location, as long as you have that internet connection, of course. Your data can be automatically backed up. You can share files with other users easily. People around the world can collaborate together on projects. And it saves space on your secondary storage because you don't need a local copy of that data or even possibly the software. Cloud applications are always the latest, most up-to-date versions, and you don't have to worry about updating anything yourself. Reduces the need for network managers and technical support staff for businesses and large companies. If you get a question on the exam about the cloud, please make sure you read the question carefully. Sometimes you'll get a situation like it's a lawyer's office or a bakery or a school. Make sure you do contextualize your answers. The cloud is an advantage for the school because the cloud is an advantage for the bakery because, and that's how you make sure you pick up all the marks. However, there can be disadvantages to the cloud. When you're using cloud software, cloud services, when you're storing data online, you do need a reliable internet connection. You also need to be able to trust your data to a third-party company. Can they handle malware, hackers, and other security concerns? So if you're a personal user and you're just storing some pictures that you've taken on holiday online, maybe that's not such a worry. If you're a big business and you're hosting, trade secrets and customer information online, you have to be confident that that will be kept secure. And of course, while some services are free, especially to start with, many charge a monthly or annual fee. I mean, if you want just a few gigabytes, you can probably get that for free with somewhere like Dropbox. But if you want 100 terabytes of space, that's going to cost you quite a lot of money. In summary, there are many different technologies we need to make the internet work. So these include things like URLs, the web addresses that we're familiar with, IP addresses, the address of every computer device that's located on a wide area network, DNS, domain name system, that's how we match URLs and IP addresses. We've got hosting. We've got the idea that we need to put websites and resources on a web server to host them somewhere so they can be accessed from around the world. And we've got the idea of the cloud computing, putting software, services, and data online, which has a variety of advantages and a few disadvantages. That'll be all from me for today. Good luck with the rest of your studies. See you in the next lesson.